In this video, we're looking to combine two of Photon Design's most powerful tools. FIMMPROP is our eigenmode expansion simulator, where we're going to rigorously simulate components, and we're going to be learning how to export those rigorously simulated components to our PIC simulator, PICWave, where we can perform 3D time domain active simulations on a large PIC scale.
Okay, so I'm here in PICWave, and in this example I'm trying to design a Mach-Zehnder interferometer. Except rather than using one of PICWave's Y-splitters to split light into these two arms of different length, I would like to use a FIMMPROP component. I'm going to use an MMI. To do this, I'm going to add an FIR filter in my device here in PICWave. So once I add this FIR filter, if I right click here, there's a button that says connect to FIMWave. So with your instance of FIMWave open, you can see I have one here. I have one project open called the MMI, but if I press send to FIMWave, it will now generate a new PICWave device. So I've got two different sections here, PICWave device and PICWave variables, and I could build my component here, but most of the time you're going to be copy and pasting an existing component into this. So this is an MMI coupler that I've made already in FIMMPROP, and just to show you what this looks like. Here is my frequency domain result using eigenmode expansion. Again, this is a rigorous simulation. That means we're looking at one wavelength and no time evolving effects. So PICWave is going to have to run FIMMPROP at multiple different wavelengths and build a surrogate model of this component. And then once we're in PICWave, we can use this component in time evolving simulations with active components as well. So I'm just going to copy this MMI coupler into the PICWave device. I'm just going to copy and paste in my epi structure. I'll copy and paste in my MMI coupler. Delete PICWave device. Rename this to PICWave device, and then I don't have any variables I need to transfer over. It's important to note that when setting up the PICWave device, I have used ports, one input port and two output ports. This will define how many connection nodes I have in PICWave. So back into PICWave now, I'm going to press retrieve from FIMWave, and we'll be able to run these simulations. So I don't necessarily need all of the information that FIMMPROP can offer. Maybe I don't need all the reflecting components. I just want the left to right transmission here. So I'm going to turn off the right to left, left to left, and right to right components of the scattering matrix, just to make this a little bit faster. And then of course I want to have multiple wavelengths, just to check in what wavelength we were operating at. So we're operating at 1550 here. So let's have a little range here of 1.53 to 1.57 and have 10 values of the wavelength between there. And then I press calculate in FIMWave. Now PICWave is in control of FIMWave and is running 10 different simulations, and then we're going to build a surrogate model based on those 10 different wavelengths that we've run at. So that's all completed there. Let's have a look. So firstly, we can see we now have one input port and two output ports, just like our model does in FIMWave. and we can see how this device actually is behaving. So this is the power coupling coefficient on the left hand side of the axis and the wavelength on the right hand side. You can see this device is fairly wavelength invariant, but there could be much more dramatic effects. So this is why it's worth bringing over rigorously simulated components over to PICWave. And one final touch is that you can change the bitmap of your FIR section just to keep track of all the different components that you have. So now this component is now ready for multi-wavelength time domain and simulations with active components here in PICWave.